Okay, so now let's see the second problem. So the second problem is there exists t for any x that phi cosine x minus cosine phi x plus t is less or equal to b. So we're going to find the least value of b. So after all we're going to do, you see, this function is going to be less or equal to b. Of course, we know t is changing, right? So that means this function, we can think this function's greatest value are changing. So that means, and you see this function is going to always less than or equal to b. So that means this function's greatest value is b. So we're going to find b's least value. So that means we're going to find the least greatest value of this whole function, because t is a variable. So this actually is a bivariate problem, because we have two variables. Bivariate actually means we have two variables. Okay. So now let's think this problem. So first let's find the second problem out. Okay, I just line it here. Okay, don't forget. Okay. So now what we're going to do is to think about this problem. So first we're going to think about this problem, what you're going to do. Okay, so let's think. So first we're going to think about the picture. Right here, so I'm going to draw this picture again. Okay, it's like this. Okay. So there are two piles over here. Good. It's over here, so it's over here. Okay, something like this. Okay, now let's draw another one. Okay. Now let's see what I'm thinking. So the first time when x is equal to 0, right? So it's this value. Then actually it's 4. So we can draw another picture with this value. Then the next thing is that we will move once again. So this value is going to be greater. Right? Because in this picture, we can imagine that this function Okay, now let me tell you one thing. Now this one is when t is equal to 0. So it's here is cosine phi x. Okay. So the first, the second, when we have a dx increment. So right here, the increment of cosine phi x is greater than the increment of phi cosine x. So now then the value is getting greater because we find cosine x to minus cosine phi x plus t, right? Okay. And greater. So if you calculate, so it's the point right here. It's a point we can think it's a pi over 6, and when it's in this point, so its value is almost right here, right? And this value is the greatest value. It's the greatest value of the whole function. Now because it's when t equals to 0. This is the greatest value. So what about the next second? We can think in this second that the slope of these two functions are the same. And when we go to the next second, and this slope is getting faster, but this slope is getting slow. So that means what happened? You see, this goes much more faster. This goes slower. So that means the difference is getting smaller and this one is this guy is getting up, so getting less, and now it's 0. Okay, so we can imagine something like this. Okay, so we can draw out this picture. Let's think. Okay, something like this. Okay, something like this. Okay, so now let's imagine. The value is just, you see, first it's 4, then it's getting bigger, then it's getting smaller. Smaller to 0. Okay. So now let's imagine. Now t is getting bigger. Okay, so what happened? Now this function, cosine phi x, this function is getting moved to left. So normally we think, hey, of course, now let's think the greatest value is right here, right? Okay, now it's getting, okay, we move there, it's getting bigger. Okay, then this shall be the least value. Now, they look at it like this, but actually it's wrong because the x value of the greatest value is moving left, right? So what I know it's moving to left because you think, right here, if we move to the next second, and right here, the value that you're getting last, the moving, because if you're getting left, so sorry, if you're getting right, so the value is like this. Because here we can think these increments, because the increments getting smaller here, so the increments very fast, getting smaller. But right here, you see, if you get left, so this guy's increment is getting smaller because when you move here, you see, actually the increment right here is getting smaller. So who's bigger? So the greatest value go the place that you can ensure the place go to left or right. You see, this guy is increment like this, but there is a problem. Don't forget, this guy's value need to times phi, so that means the increment is very big, so it's very big. So that means this guy's increment is greater than this guy's increment, so of course the greatest value go with this function to the left. So that means the greatest value is not here anymore. It is getting left and it's getting bigger. is like this, right? So that means you actually knows the greatest value is getting left, right? That is this point. Okay. Now, we can imagine, so we can think that what are we actually doing? It's the same with we're suppressing all the peaks of this function because you think in here, right here is we can think the greatest value is moving left, so this greatest value is moving left and is getting bigger, some kind of like this. Okay, so this point, actually, I will tell you why later. Actually, this value right here is getting there. It's getting less. Okay, let me tell you why later. This guy is getting less and getting left. I will tell you why later. So actually, we can imagine the whole function when t is getting bigger is like this. The whole function is gonna move to left, and this guy is much more higher, and this guy is much more lower, and this guy is also getting lower. So it just looks like So we actually are doing why we think this function when t equal to 0 is the right answer, because we actually what we're doing, we're suppressing all peaks of this whole function and f of x, this whole function. So to prevent to prevent all peaks from being too big, right? We're actually doing this way. So we actually doing similar. It's similar to adjusting parameters to let the function to get much more flat, because you see this function, what is doing? You see these two greatest value, they are the same high, and when t is getting bigger, it's just this one is getting lower, this one is getting bigger. So we'll let this function get to much more flatter, right? So we're going to adjust the parameters to let this whole function to get much more flat. So this is what you're going to do. Okay, so now let's talk about the secret of this problems. Okay, so if we think the secret, so first we need to know the greatest value. So we're going to derivative this. Okay, so first we derivative this function. Good. So if we derivative this function, it shall be this part shall be negative phi sine x, right? Okay, then we minus, so it would be a plus, right? Then we use chain rule, so it's plus phi multiple of what? Phi multiple of sine phi x plus t. Okay. Then we're going to do this because this is the derivative function, so we're going to let it go to 0. So we move this part here, and phi is being cancelled out, so sine phi x plus t is equal to sine x. So we think about the relationship of phi x plus t and x. So if we think circle over here, now what happens? So if this is a angle, this is x, this angle. Ugh. This is x, this angle. This angle is x. Now what do we think about? Now if this angle is x, good. This angle is x, so we're thinking about phi x plus t. Of course, at first, so what will happen? We can set it as, let's think, it is equal to x what? X plus 2k pi. Right, so it's always in this place. So of course, they're equal to. So another thing, because it's sine, so here's also fine. So it's pi minus x, right? So phi x plus t is also equal to pi minus x and then plus 2k pi. Okay. Okay, so now let's see the next step. So that means we have, if it's this, so we can move x to here. So it's 4x, and we move t to here. So it's 4x equal to 2k pi minus t. So then we divide 4. Then we divide 4. So x is, both sides divided 4, so x is equal to what? Let's see, x is equal to 2k pi minus t over 4. Okay, now what's this? X is equal to, right, because we move x here, so it's 6x, right? It's 6x, and we move t here, so it's 6x, and it's equal to pi minus t. Then what we do? Then we plus 2k pi, right? Okay, great. So now this one, x is gonna equal to, and you see, here's a 2k pi, and here's another pi. So then of course, we move 6 here, right? Okay. So it actually happens like that you shall be, we can because it's a 2k pi and another one is pi, so it's 2k plus 1 multiple of pi, and then we minus t, and then over 6. So what do you find out now? You say, okay, here is 2k, and here's 2k plus 1. So k is any integer value. Okay, so let's see. 2k, great. So 2 times any integer, so that's a even number. And it's 2k plus 1, of course. 2 multiple of any integer number, then plus 1, that's an odd number. So that means we can change k to k prime. Now this is when k prime goes even. So we can substitute it with k, and right here is with 2k. Then right here is k prime equal to k prime. Yeah, it should be, now this one is k prime equal to odd. So right here we substitute it with 2k plus 1. Good. Okay. So now it's like this. So that means this one, and also now the next step is we're gonna plug it in, write the original function. So if we plug in our original function, let's see here. So first it's phi cosine x, phi cosine this angle, and you see, so we minus a cosine phi x plus t. And so what's phi x plus t? You see right here, phi x plus t equal to x and then plus 2k pi. So we can change phi x plus t to x plus 2k pi. So we're living cosine x plus 2k pi. Of course, we know x is just this part, right? And the cosine this part and then plus 2k pi cancel out. So we have phi cosine x minus cosine x. So 4 cosine x, right? Good. Good. Okay. Let's see. So that means this is 4. This is when k prime equal to even. So we have 4 cosine, what? 4 cosine, 4 cosine, let's see. 4 cosine right here is, it is k prime multiple of pi and then minus t, and then over what? Over 4. Okay, good. Now this is, let's see, it should be k prime equals odd. So right here, now this is, hey, here's pi minus x. That's different. Now, okay, fine. Phi cosine x. Okay, fine. Now, phi cosine x, no change. And here's minus cosine phi x plus t. Now, cosine phi x plus t is equal to pi minus x plus 2k pi. So, if example, x is right here. So, pi minus x is right here. And 2k pi could be canceled out. So, if it's right here, cosine value is negative. So, we can just that means we can cancel out the pi and the negative front of x, then we change it to a negative sign front of cosine. Okay, so now here's a negative first. So now it should be positive. Good. So if k prime is equal to odd, so that means it shall be 6 cosine. 6 cosine of what? 6 cosine. Let's see. Okay, this is 6 cosine x, right? So because it's going to be cosine plus cosine x. 5 cosine x plus cosine x, so it's 6 cosine x. So x is just k prime, so it's 6 cosine x. Okay, let's see. Here's k prime multiplied pi and then minus t over 6. Okay, so now we actually have two pictures. Because here's the full cosine k pi, here, this part. We can actually imagine. This part is, no, not imagine, think. This part actually is x, right? This part is actually this x. Okay, so now k prime is really even. Okay, so now let's draw. This is the final thing. So, the point is right here. Now this picture, it looks like something like, okay, great. This part, we just draw to here. It's okay. It's okay. It's fine. This is the x-axis, don't forget. This is actually f of x. Right? This is actually f of x. So let's draw another one. Okay, so this one is a little bit higher because it's 6. Good. Okay. Okay, I just try here. No. Okay, it's okay. Now, another thing, don't forget what is our aim? We're going to find, don't forget our aim, because our aim is to find the smallest, greatest value of this whole function. So now we have these two answers of the greatest value, so we're going to find every least value of both of these two true of greatest value. We're going to find the least greatest value in both of them, then compare their least value. Right, that is like this. This is like this. Okay. Okay, now let's think about this picture. Okay, x, f of x. Okay, don't forget. Here's when k prime equal to odd. Okay, now let's see this picture. This picture right here. So first, this point actually is when k, so first we're going to think about when t is equal to 0. So this point actually is when k prime equal to 0. And then this point is k prime equal to 2, and 4, and then 6, 8, 10, just something like this. Okay. So now let's think about it. So when, let's think, from k prime equal to 0 to equal to 2, how much do we move? Actually, it's 2. It shall be 2 pi over 4. Okay, 2 pi over 4. So we can think that is, first we move 1 pi over 4, then we move another pi over 4. So that is, first we move 1 pi over 4, then we move another pi over 4. This is pi over 4. Then this is 2 pi over 4. Good. Some sort of like this. Okay. So it's just like this. Alright, so now let's think what happened. This point is k prime equal to 0 and 2. So now we're going to move t. So t is left of this part, x value is going to be less. So we move left. So first we can imagine. First we move left 1 power 4 here, because another one is right here. So let's think like this. Then we move another one. First it's like and we move another one. Right? Okay. So some sort of like this, right? Okay. So now if you say, okay, so every point is moving. I know that. Okay, now if you move here, fine. And if you move here, okay, I'll tell you this later. Now let's see this one. Now you sort of we can say here to integral, okay? Now you sort of has something about this problem. We actually have so this point is when k prime equal to 1 and k prime equal to 3 and k prime, yeah, and here is k prime equal to 1 equal to 5, and this one is k prime equal to 7, and so on. This point and this point, something like this. Okay, so now this is the point. Now if we match right here, it's because from k prime equal to 1 to equal to 3. Now this interval, so first one k prime equal to 1, this interval is power 6. Okay, then we move another 2 power 6. Now I know it should be right here, right? Okay. Okay, it's like this. So here it is when k prime equal to 1. Okay, so here is 2 pi over 6. And right here it is 3 pi over 6. Okay, great. Now I see. These 2 points, now because now he writes, now it is t equal to 0. So t is getting bigger, right? And so first we move 1. Okay, now let me draw another point right here. Actually, let me tell you. Right here, this is also a point, so we know this is when k prime equal to -1. Okay, so okay. This is symmetry. Right here. So you can imagine it's like this. So first the point right here, then we move 1 power 6, boo. Then we move another one, boo. Then we move another one, boo. Then move another one, boo. Right? Great. Okay. So something like this. So this is in the Descartes coordinate system. So what we're going to think about it is when we are in the polar coordinate system. So this is another problem, right? Okay. Let's see. First we're going to draw a circle. Okay. Now let's see. Okay. Okay. Not this point is over here. Okay. Good. Now first let's see this one. This one, so first it's saying k right here is k prime equal to 0. So next one is when we need to draw the interval when it's power 4, so okay. Now k prime equal to 0, k prime equal to 2, k prime equal to 0, k prime equal to 2. Then k prime equal to 4, right? Because this is another interval. And this equals k prime equal to 4. another interval. And this is the k prime equal to 6, another interval, and also k prime equal to 8. Okay, so this angle is pi over 4. Good. So this is how we move right here. So now we're going to think about how we move, right? So we know this is actually, now let me tell you. This we know it's k prime equal to 2, right? So we actually know here it is with k prime equal to 1. Sorry, -2. Good. Okay, so right here, what it look like? So first one is right here, and another one is right here. Now we move, okay? Because t now right here now, t is equal to 0. Move to here. Here, and if we move one more, so this guy is going to be the greatest value, because right here, this guy's the greatest value, and move here, this guy's still the greatest value. Actually, you can say this guy equal to this guy, so both of them are the greatest value, and we move one more than this guy, because the greatest value. So, the domain that the greatest value can choose is, okay, let's think. From here to here. This part, right? Good. Now let's see the next thing. What I'm gonna do next is that, let's think. Now we're gonna think about when it's this one, this picture. So it's k prime is equal to odd. So first one is when k prime is equal to 1, some sort right here. So this angle is pi over 6. Okay, so the next thing is over here. Okay, this is another angle from here. Okay, so right here, this is just an interval. This is not where k prime equals 3 is. K prime equals 3 is right here, right? Now then, this is another interval. This is another interval, so k prime equals to 5 is over here. Good. Then k prime Let's write it here, right? Okay, this is, now let me draw the points. This point, this point, this point, okay? And then right here. It's right here. Okay, then it's right here. Okay. Let's think. This is when k prime equal to 7. This isn't a point. This is an interval. Not in here. Sorry, this is an interval. No, it's not right. This is a point. Good. It's not right. Fine. This is a point. No. Yeah, this is a point. Okay. One angle, another angle. You know, it should be over someplace over here. Okay. This point, this point, this point, this point, and then this point right here, and then let's continue. Okay, this is when k prime equal to 1, k prime equal to 3. Okay, move. Okay, let's see. This one is in it here. Okay, this is when we move one interval, another interval over here. So it's here. Then we move. Okay. And next time you hear, then this guy will be the greatest value. So the greatest value now we can say is this one, this region. Okay, so now the greatest value of when k prime is equal to even in this region, so the least value is right here. And now another one is when k prime equal to odd, so the region is right here, right? And if the region is right here, so the greatest value is this, or we can say this, so we just say this. So we're gonna compare with, use with 6 because okay, we think about this is a polar coordinate system, so we don't have the 4 and 6. So now we're gonna times it on. So it's 6 cosine. Okay, this angle, right? This angle is cosine pi over 6. And another one is 4 cosine. Okay, it's a 4 cosine. See here, it's a because it's cosine, so it's no one for negative, and that's a pi over 4. So if you compare them, you will find out 6 cosine pi over 6 is greater. So why we choose this solution, we will talk about later. So, and it's equal to 3 square root 3. So this is actually an answer. So I'm going to tell you another thing. Okay. Another thing is we can think about the upper limit and the lower limit. And if we think about this picture, so we can think the upper limit is right here because the range, this range, it's right here because we can move here. Move 1, move 2, and then we move 1 more. This got to be greatest value. So it should be move when we move to here. So this is it. Okay. So the range is from here to here. Now we can think right here the upper limit is right here. And if it's right here, so the upper limit is defined by t. So because every point you're here, when we just move one value, when we move a t, then we can move it to here. Here, this point move it to 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 here. It's always okay. But there's a problem. We're gonna think about the lower limit. If we think about the lower limit, it is actually defined by k prime. We think at k prime, so what I can define? Of course, we can think. It is also, well, if you want to move to this point, of course you use t, but there's a problem. The lower limit is you need to be sure there's nothing, it is even less than it. So if you only have 1 point, okay, after this point I still get down, so that's less than this point's value. So the lower limit is not right here. Of course it's not. Why? Because when k prime equal to 1, right, move right here, so equals 3 will move to here. That is the property of k prime. So we can say the lower limit is defined by k prime. Okay, so actually, this is what I want to say. Right here, actually, just if in that picture, the polar coordinate system, it just first let's write these 2 points, and we move to here. Okay, we just move 1, here, then it just moves it here. Then we can't continue move to there, or this guy will be the greatest value. Okay, so that's it. The range is over here. Good. Range is over here. Okay, so we know the upper limit and lower limit are the same. So last thing I'm gonna tell you is we can put these two pictures, all of these point back to this point, this problem. So we can think this point was this. Okay, here. Where do you see this value 4, 4? Okay, here just actually this value 4. Okay, so actually we see this point, it is this point. So what are these two guys? These 2 points. Okay, we just think about these 3 points. So now you can know why. At first, when we think about this picture that t is gonna move, we can move. So what about here? Every t point is getting left, 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 right? Okay. This point higher. This point lower. So these 2 points is another these 2 points, and we actually notice these 2 points are getting down, are getting lower, and these 2 points right here are getting higher. And what about this point? Getting lower. Every point right here is getting lower, 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 lower. So we can think all of these guys are getting left, but there is a problem. This guy, every time he moves, is power of 4, and this time every time, because we think we have a timeline, and this is every time we move power of 4, and this is every time we move power of 6. So this guy is slower than this guy. So we can think these 3 guys move here. I can't really think about it. I can't really draw to you really good, but you can imagine. This one is much more faster, but these 2 guys are slower than, much more slower. And it's much slower, not much more, not very more, just slower than it. Okay, so this guy move up, okay, then it get left, and it get more higher. Then this guy much more lower. And this guy is getting much more lower. That's why at first we're gonna say adjust the parameters, right? We actually suppress all peaks of this function because we're gonna let it be the same. We're gonna just think about it like this because we're gonna think about the geometric meaning, right? Some kind of this. So we can just think about it like this. Okay. So this is what I want to say in the original picture, because this 2 pictures, all of these points, you can project it back to this function. Okay. This will so of course now we also know the answer. That means the answer is t equal to 0 and x is equal to pi over 6, and then there's another thing. Okay, the answer is 3 square root 3. Okay, it's not the answer. The answer actually is b, right? So you can write the answer b is equal to 3 square root 3. Good. Okay, so this is how we solve the second question. So today we're going to talk about the first question and the second question. So I'm going to add 2 details over here. So the first detail is, why can't we decide K's place, K prime's place when t is equal to 0? So the first thing is that, so first we're going to derivative the original function, then we let it equal to 0, then we have the x value. So then we depart it to when K prime is even or odd. So we have these 2 graphs, and so over here just we have these points. And right in this graph is just these points. And all of them are the stationary point. Okay, this is the first detail. So the second detail right here is, at last right here, why I choose this solution. So if we think about it in the polar coordinate system, so this solution, the range of this solution is over here. And the range of this solution, actually we shall think is over here. It's not over here. It should be over here. Then, so we compare. We use the the least solution of this solution. So it's, we can say it's this value, this point or this point, and we compare it with the greatest solution of this solution. So it's because it's this range. So it's over here. So it's this point. And don't forget we're gonna times the 6 and 4. So, and you'll find out the least value, the least solution of this solution, it is bigger. So that means this solution is greater than this solution all the time. So this is in the polar coordinate system, so we can move it to the Descartes coordinate system. So in Descartes coordinate system, you see here, the range is over here. Here, the range is over here. So you see, this range is the value over this, the solution over here, it is greater than the solution over here all the time. So, and according to what the the question means, we know that so we know that we're gonna choose this solution. So the least value of this solution, because we're very lucky, because we know that this solution is greater than this solution all the time. So we only need to care about this solution. So we actually need to find the least value, or can say the minimum value of this solution. So it's actually calculated out as 3 squared is 3.